Mathematics, Paper 1, Higher Tier, May 2019. This paper is for 1.5 hours. And some of the instructions that you have to take into consideration before the paper. Paper 1 is non-calculator paper. Calculators are not allowed. You must show all your working. Marks for each section are shown in brackets, and this is as a guide as to how much time to spend on each question. So if a question is like 3 marks, it gives you an idea that you should spend about 3 or 4 minutes for that question. Keep an eye on the time. Try to answer all the questions. Answer all questions. And most important, check your work at the end and make sure you answer questions in the spaces provided and write neatly. Good luck. Question number 1. There are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. Color blue, probability 0.2, red and yellow. The number of red cubes in the box is the same as the number of yellow cubes in the box. Complete the table. So the total probability has to add up to 1. So 1 minus 0.2, it gives you 0.8. Half that, it gives you 0.4. So red is 0.4 and yellow is 0.4. And if you add them, they will give a total of 1. 0.4 at 0.4 at 0.2 gives you 1. Next section. There are 12 blue cubes in the box. Work out the total number of cubes in the box. If 0.2 represents 12 cubes and 0.2, if you change it to percent, it's like 20%, multiply by 100. So 20% is 12 cubes. You double 20%, you get 40%. 40%, you also double the 12 cubes, it will give you 24 cubes. So 24 cubes represents 40%. Or if you multiply 20% by 5, you get 100%. That means you multiply 12 cubes by 5. Or you multiply on the right, you multiply the same on the left. So 60 cubes is the answer. So, or you can get 24 cubes plus 24 plus 12. It gives you 60. Question number 2. Dion needs 50 grams of sugar. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter as sugar. Dion is going to make 60 biscuits. Work out the amount of flour she needs. So 60 divided by 15, it gives you 4. So for 15 biscuits, so you times 4 to get 60 biscuits. 550 grams of sugar, because it's 3 times as much flour, you will do 3 times 50 grams of flour, and then you will times 4, and that will give you 600 grams of flour. For the butter, it's 2 times 50, and then you times that by 4, because you're making it for 60 altogether. So 2 times 50 times 4, it gives you 400. So that means Work out the amount of flour she needs. For the flour, she would need 600 grams of flour. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250-gram packs. How many packs of butter does Dion need to buy? 250-gram packs to another 250, you add it together, you get 500 gram. Because she needs to buy 400 grams of butter, so she will need to buy 2 packs and use 400 grams, and she will have 100 left. Question number 3. Find the highest common factor of 72 and 90. You can draw a factor tree. 72, 2 times 36. 2 is a prime number, so you circle it. 36, 2 times 18. 2 is a prime number, you circle it. 18, 2 times 9. 2 is a prime number, you circle it. And 9, 3 times 3. 3 and 3 are prime numbers. And you can list them. 72 is the same as 2 times 2 times 2 times 3 times 3. You can list prime factors of 72. You do the same for 90 for work out of prime factors. Because an even number, I use 2 times 45. Half of 90 is 45. 2 is a prime number, we circle it. 45, 5 times 9. 5 is a prime number, you circle it. And then 3 times 3. 3 is a prime number, 3 is a prime number. And you can write out the prime factors of 90 as 2 times 3 times 3 times 5. Now you look at what is common or found in both of them. 2 is found in both of them. 3 is found in both of them. Another 3 is found in both of them. And to get the highest common factor, you multiply those numbers that are found in both lists. 2 times 2 times 3 times 3. 2 times 3 times 3. And that gives you 18. So the highest common factor of 72 and 90 is 18. Question number 4. The diagram shows the plan, front elevation, side elevation of a solid shape drawn on a centimeter grid. In the space below, draw a sketch of the solid shape. Give the dimension of the solid on your sketch. So the solid, if you look from the top, a bird's eye view, you see a plan, and the diameter is 4 centimeters. And when you look from the front, you will see a shape which looks like a rectangle. And if you look from the side, you will see a shape which looks like a rectangle as well. So to draw it, that's the plan from the top, the yellow part, and it's like the top part of a cylinder of this tin of baked beans, the top part. When you look from the front of it, you see that label, and you will see that dimension. You see that rectangle and that label. That's what you would see. And when you look from the side, you will see the height of 5 centimeters, and you also see a rectangle. So that is the shape of the solid which you would get when you draw it and you give the dimensions 4 centimeters, 5 centimeters. Question number 5. Shape A can be transformed to shape B by a reflection in the x-axis followed by a translation CD. Find the value of C and the value of D. So you start with shape A, you reflect it, and then you translate it. When you reflect it, you want the mirror line is the x-axis. That's the mirror line. So the mirror line is that pink line there. which represents the x-axis. That's where you put the mirror. So A is the object. This blue triangle is the image, because you're having a mirror, object and image. And then after that, you would have to translate it. To translate it, you want to move it to part B, where B is. You can count moving it to the left. 1, 2, 3, 4, 5, 6. You move it 6 places to the left, and then you move it 1 place down. When you move to the left, you use a minus, -6. And when you move down, you use a minus. So 6 places to the left and -1 down. So the translation is -6 -1. Question number 6. A shop sells packs of black pens, packs of red pens, and packs of green pens. There are 2 pens in each pack of black pens, 5 pens in each pack of red pens, and 6 pens in each pack of green pens. On Monday, number of packs of black pens sold is to number of packs of red pens sold is to number of packs of green pens sold. 7:3:4. A total of 212 pens were sold. Work out the number of green pens sold. So we write it 7:3:4. 7 times 2, because there are 2 pens in each pack of black. 7 times 2 is 14. 5 times 3 is 15, because there are 5 pens in each pack of red pens. And 6 times 4 is 24. You add the total. You add them to get the total. 14 plus 15 plus 24 is 53. And what you do is 212 divided by 53, it gives you 4. So you multiply 24 times 4, it gives you 96. So first of all, work out 7 times 2, 3 times 5, 4 times 6. And then you add them up, it gets 23. And 53, 212 divided by 53 gives you 4. And 24 times 4 is 96. Question number 7. Here are 2 rectangles. QR is 10 centimeters. BC is equals to PQ. The perimeter of A, B, C, and D is 26. The area of P, Q, R, and S is 45 centimeters squared. Find the length of AB. So we look at P, Q, R, S and work out the area. The area of a rectangle is length times width. So we multiply 10 times X. It should give us the area of 45 centimeters squared. But what number do you multiply by 10 to get 45? 4.5. So X is 4.5. Now you know X is 4.5, which is PQ, and that value is the same as BC, which is 4.5. Now we work with perimeter. Perimeter of A, B, D, and C. Perimeter of that is 26. So perimeter means you add all the distance around the object, at all the sides. Since AB is the same as DC, we will write 26 is AB plus CD plus 4.5 plus 4.5. 4.5 plus 4.5, it gives you 9. AB is the same as CD. We can write it as 2AB. So 26 is equals to 2AB plus 9. since AB is equals to CD. Now, 26 minus 9 is equals to 2AB. 26 minus 9 is 17. Half of 17 is 8.5. So AB is 8.5. Question number 8. Work out an estimate for the value of square root of 63.5 times 101.7. It says estimate. So we use numbers that are easy to do, work out the square root of. And I would look for square numbers. So 63.5, you would choose 64 because you can work out the square root of 64. 101.7, you would use 100 because you can find the square root of 100. And using this formula on the top right, square root of A times B, square root of B is equal to square root of A times the square root of B. So you find square root of 64 is 8 times the square root of 100 is 10. So 10 times 8 gives you 80. Next part. 2.3 to the power 6 is equals to 148. Correct to three significant figures. Find the value of 0.23 to the power 6. Correct to three significant figures. Let's look at what is inside the bracket. 2.3 divided by 10 is 0.23. So what is in the bracket, we can replace it with 2.3 times 1 over 10. It's the same as 2.3 divided by 10. Now it raised to the power 6. So 2.3 divided by 10, you can change it to 10 to the power minus 1. So it's 2.3 times 10 to the power minus 1, all to the power 6. And this power 6 is for both of them, for both numbers in the bracket. So 2.3 to the power 6, 10 to the minus 1 times 6, minus 1 times 6 gives you minus 6. So you got 2.3 to the power 6 times 10 to the minus 6. And from the beginning, they told us 2.3 to the power 6 is 148. So you write 148 times 10 to the minus 6, which is what you can write as 0.000148, or 148 times 10 to the minus 6. Part C, find the value of 5 to the power minus 2. To get rid of the negative power, you reciprocal 1 over 5 squared. 5 squared is 5 times 5, which gives you 25. So it's 1 over 25. Question number 9. Work out 3.5 times 1 3/5. Give your answer as a mixed number in its simplest form. To do that, we can change the mixed number 3.5 to an improper fraction. 3 times 2 is 6 plus 1 is 7. So that gives you 7 over 2. Change the next one. 1 times 5 is 5 plus 3. That gives you 8. 8 over 5. Now we've changed both of them to improper fraction. We can simplify first, or we can just multiply and simplify after. 7 times 8 is 56. 2 times 5 is 10. 56 divided by 10. How many 10s go into 56? 5 of them. Remainder 6 and over 10. Half of 6 is 3. Half of 10 is 5. So your answer is 5 3/5. Question number 10. The graphs with equations 3y plus 2x equals to a half, and 2y minus 3x equals to minus 113 divided by 12 have been drawn on the grid below. Use the graphs to find estimates of the solutions of the simultaneous equations. So to find estimate, you look for where the graphs meet. The meet at that point in the middle there. And if you go up, it would be 2.25 for x. And if you go to the left, the minus 1.3. So for x, 2.25, and for y, minus 1.3. It should just be 2.25, not minus. X is positive. 2.25 and y is minus 1.3. You look at where they meet and you read the value for x and the y axis. Question number 11. A bus company recorded the ages in years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. Complete the table below to show information about the ages of the people on coach A. So median, lower quartile, upper quartile, least age, greatest age. Least age is 41 on the list. Greatest age is 79. And since the numbers they are put in order from smallest to biggest, to get the median, that's the median there, 59. So half of them are on the left and half of them are on the right side if you put it straight in a line. But you want to make sure the number on the left side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers on one side of 59, 11 numbers on the other side. Lower quartile, you divide it into 4 groups. 1, 2, 3, 4, 5. The next one, 1, 2, 3, 4, 5. The next one, from 60 to 64, another 5. 67 to 79, another 5. So the lower quartile is 53, upper quartile is 66. So, or you can use 23 plus 1, n plus 1 over 2, that gives you the 12th person. 11 plus 1 over 2, it gives you the 6th person, which you can count. Second part, here is some information about the ages of people on coach B. The median is 70, lower quartile 54, upper quartile 73, least age 42, greatest age 85. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? Yes, it's correct. You must give a reason for your answer. Let's look at coach A. The median for coach A is 59. And the median for coach B is 70. 59 is less than 70. So that shows that coach A are younger than coach B. And or you can say all statistics values are lower for coach A, so they are younger. And because the median age is smaller. Question 11, part C. Richard says that the people on coach A vary more in age than the people on coach B. Is Richard correct? You must give a reason for your answer. We look at coach A. The range is 38, which is 79 minus 41. The interquartile range for coach A is 13, 66 minus 53. Let's look at coach B. The range is 43, 85 minus 42. The interquartile range is 19. 73 minus 54. So coach B has greater interquartile range. Or you can say coach A has shorter interquartile range. So the answer is no. People on coach A do not vary more than people on coach B. Question number 12. Here are three spheres, P, Q, and R. The volume of sphere Q is 50% more than the volume of sphere P. The volume of sphere R is 50% more than the volume of sphere Q. Find the volume of sphere P as a fraction of the volume of sphere R. So with this type of questions, we can just pick a number, say 100 for P, and we can work from there. So 50% of that 100 is 50. So Q is 100 plus 50, that gives you 150. So it says the volume of Q is 50% more than the volume of P. So if P is 100, Q would be 50% more, which will be 50 plus that gives you 150 for Q. And then 50% of that 150, it gives you 75. Because the volume of sphere R is 50% more than the volume of Q. So we want to find 50% of that 150 for Q. It gives you 75. So R would be 150 plus 75. R is 225. So we want to find the volume of sphere P as a fraction of the volume of R. So volume of P divided by volume of R. Volume of P is 100. That's what we chose in the beginning. 100 divided by the volume of R. The last one we found was 225. When you simplify that, it gives you 4 divided by 9. 4 over 9. Question number 13. Given that n can be any integer such that n is bigger than 1, prove that n squared minus n is never an odd number. N squared minus n. If you factorize n bracket n minus 1, so if n is an odd number, n minus 1 will be an even number. So whenever you multiply an odd number times an even number, you get an even number. The other way around, if n is an even number, n minus 1 will be an odd number. And whenever you multiply an odd number and an even number, you get an even number. That's one way of doing it. Or you can write n squared minus n. So if n is even, an even number squared minus an even number gives you an even number. If n is an odd number squared minus an odd number will give you an odd number. That's another way you can prove it. Question number 14. Find the exact value of tan 30 degrees times sine 60 degrees. Give your answer in its simplest form. The important thing here is exact value. So you need to memorize how to get that values for tan 30 degrees and how to find out the value for sine 60 degrees. And one of the ways that is common is to use a triangle. I've made some other YouTube video which shows how you can use another method to work out tan 30 degrees and sine 60 degrees. And this triangle is a very good one. All you need to do is to remember an equilateral triangle with each of the sides 2, 2, 2. And then to remember that in an equilateral triangle, each of the angles is 60, 60, 60. And then you can divide it such that you will get 30 for one of them, and then you do a straight line. And that will split one of the sides into 1 and 1. And you can use Pythagoras theorem. 2 squared minus 1 squared square root will give you square root of 3. Now you can work out those tan 30 degrees and sine 60 degrees. Tan 30 degrees is opposite over adjacent. From 30 degrees, opposite is 1, adjacent is root 3. So it's 1 over root 3. Sine 60 degrees, opposite over hypotenuse. Opposite is root 3, hypotenuse is 2, root 3 over 2. Once you get those values, you multiply them together. The root 3 and the root 3 would cancel. So you just have 1 times 1 at the top, it gives you 1. And 1 times 2 at the bottom, it gives you 2. So it gives you an answer half, 0.5. So the important thing is to remember that triangle, an equilateral triangle. All the sides are 2, and then 60 degrees angle. And then from there, you can work out tan 30 degrees and sine of 60 degrees. Question number 15. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 10 centimeters. The base of the cone has a diameter of 6 centimeters. The hemisphere has a diameter of 6 centimeters. The total volume of the shape is k pi centimeters cubed, where k is an integer. Work out the value of k. Okay, we start with the cone. We have the formula for volume of a cone at the top right. Volume of a cone is 1/3 pi times radius squared times h. We use that formula for the cone. 1/3 pi times the radius is 3. The radius of the cone is 3. So it's 3 squared times the height is 10. The height of the cone is 10. That gives us 30 pi. The sphere, at the top right, the volume of a sphere is given is 4/3 pi radius cube. So we work it out. 4/3 times pi times the radius is 3. 3 cube is 27. Now you would do 4 times 27 divided by 3. That will give you 36 pi. Now for a hemisphere is half of a sphere. So we got the sphere is 36 pi. We divide it by 2, halve it because we want a hemisphere. Half of 36 is 18. So we get 18 pi. Now we want the total. We want the cone plus hemisphere. Cone is 30 pi. Hemisphere is 18 pi. We add it together, it gives us 48 pi. So that 48 is like the k, because the one needs to find the value of k. So our value of k is 48. Question number 16. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, or 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. So the first pick, if you pick a number, the first pick, there are 5 numbers, pick the first number, you have 5 chances. The second time, you still have 5 chances because the numbers can repeat. The third time, you still have 5 chances. So the number of different 3-digit numbers that can be set for the combination lock is 5 times 5 times 5. It gives you 125. And for part B, how many of the possible 3-digit numbers have 3 different digits? 3 different digits. So the first time, if you pick a 5, you are not allowed to pick it again because you want to pick a different digit. So you only have 4 numbers to pick from, because you cannot pick 5 again. So you're only picking from 4 numbers, 1 to 4. After you pick the second number, you cannot pick the 4 or the 5. You have to only pick from the remaining 3 numbers. So there's no repeat. So how many of the possible 3-digit numbers have 3 different numbers? So you multiply 5 times 4 times 3. That gives you 60. Question number 17. Given that x squared is to 3x plus 5 equals to 1 is to 2, find the possible values of x. The key thing here is that equal to. The left side is equal to the right side. So if you write the left side as a fraction, it will be equal to the right side written as the similar fraction. So on the left side, x squared divided by 3x plus 5, that should be similar to 1 divided by 2 because it says they are equal. That ratio of x squared divided by 3x plus 5 is equal to the ratio of 1 divided by 2 because the sign says they are equal. Now, to solve this for value for x, we use a technique of cross multiply to change it to linear form. So the top, x squared times 2x, that gives 2x squared. 3x plus 5 times 1 gives 3x plus 5. Now you put everything to one side. 3x goes to the other side and 5 goes to the other side. 3x is plus 3x. You take it to that side, it becomes minus 3x. Plus 5, you take it to that side, it becomes minus 5. And everything that is left on the other side is 0. You factorize. When you factorize, you get 2x minus 5, x plus 1 equals to 0. So if 2x minus 5 equals to 0, x is equals to 5 over 2. And if x plus 1 equals to 0, x equals to minus 1. So your two possible values for x are minus 1 and 2.5. The main thing here is to remember the first part where the two ratios, x squared divided by 3x plus 5 equals to 1 divided by 2. This part to factorize, put into 2 brackets. That technique is good to learn it. This comes in lots of exam questions where you're asked to factorize. So you have to learn how to factorize from there to there. Question number 18. Express square root of 3 plus square root of 12 in the form a root 3, where a is an integer. Square root of 3 stays the same. Square root of 12, you can split it into 2. It's the same as square root of 4 times square root of 3. 4 times 3 is 12. So it's one of the rules of surds where you can split it up like that. 4 times 3 is 12, and you split them in the square root sign. So it's like square root of 3 plus square root of 4 is 2. Square root of 4 is 2, and the square root of 3 stays the same. So it's like square root of 3 plus 2 square root of 3. We can say like 1 apple plus 2 apples. That gives you 3 square root of 3. So treat the square root like an apple. 1 apple plus 2 apples. It gives you 3 apples. So that means if you compare with what they're asking you to do, A is that 3 there. So A is 3. Part B. Express 1 over root 3 to the power of 7 in the form root of B over C, where B and C are integers. So we want to write 1 over root 3 7 times. So 1 over root 3 7 times is like that. 1, 2, 3, 4, 5, 6, 7. Multiply it 7 times. Now, 1 times 1 times 1 times 1 7 times is 1. 1 times 1 is 1. So the numerator is 1. Square root of 3 times square root of 3, 2 of them would make 3. The next 2, square root of 3 times square root of 3, the next 2 will make 3. And the next 2, square root of 3 times square root of 3 will make 3. And there will be 1 square root of 3 left. You multiply those numbers. 3 times 3 times 3. 3 times 3 times 3, it gives you 27 root 3. Now, we want to change it such that there's no square root in the denominator. And that is what we call rationalize the denominator. So to get it to look like the question they're asking us to do, we multiply by square root of 3 over square root of 3. This is a technique because square root of 3 divided by square root of 3 is 1. So it's like multiplying it by 1, which doesn't change the answer, but it helps us to get rid of the square root from the denominator. So 1 times square root of 3 at the top, the numerator, it gives you square root of 3. 27 times square root of 3 times square root of 3 now at the denominator gives you 3. So 27 times 3 is 81. So that means this square root of 3 at the top is equivalent to this square root of B at the top there. So B is 3, C is 81. B is 3, C is 81. Question number 19. Given that x squared minus 6x plus 1 is equals to x minus a all squared minus b for all values of x, find the values of a and the value of b. This is completing the square method you use here. So for completing the square method, you find half of the value of the number in front of x, the minus 6. Half of 6 is 3. You square it. You put in bracket x minus 3 all squared. And then you minus 8. And the numbers, you get it. This is how you work it out. X minus 3 all squared, you have x squared minus 3x minus 3x plus 9. So that will be x squared minus 6x plus 9. But if you notice, the x squared and x squared are the same. Minus 6x and minus 6x are the same. So what do you have to get to remove from 9 to get 1? So you have to minus 8. So you minus 8. So the numbers are for A is 3 and B is 8. Completing the square method is used there. Hence, part 2, write down the coordinates of the turning point on the graph of y equals to x squared minus 6x plus 1. Hence means you use your answer from part 1. Hence, since we completed the square is x minus 3 all squared minus 8. Hence, how do we get the coordinates of the turning point from that? The 3 is the x value and the 8 is the y value. So it's 3 minus 8. So the 3 is the x value and the minus 8 is the y value. So the coordinates of the turning point is 3 minus 8. Question number 20. H is inversely proportional to P. P is directly proportional to square root of T. Given that h is equals to 10 and t is equals to 144 when p equals to 6, find a formula for h in terms of t. So let's start with the first one at the top. H is inversely proportional to p. That's how you write it. H is inversely proportional to p, 1 over p. Replace the inverse sign with equals to and k. So h is equals to k divided by p. Sub in the numbers. When h is 10, p is 6. Sub in 6 for p and 10 for h. And you can work out k. 10 times 6 is 60. So that gives k to be 60. If k is 60, you can write the equation as h is equals to 60 over p for that first part. Now, the second part says p is directly proportional to t. P is directly proportional to square root of t, not t. So p is, replace the proportional sign with equals to and a k. So p is equals to k times square root of t. See what we've replaced proportional with equals to k. Same like for the first one, we replace the proportional sign with equals to k. Now you sub in some values. P is 6 and t is 144. You solve it to find the value for k. So square root of 144 is 12. So 6 equals to 12k. You divide by 12. 6 divided by 12 is k, equals to k, which is a half or 0.5. So you can write the equation as p equals to 0.5 square root of t. Put these two together. Follow that pink line. H is equals to square 60 divided by p. Instead of p, we replace it with 0.5 root t. So instead of p, we bring the 0.5 root t and replace it there. And then 60 divided by 0.5 is 120. So you can write h is equals to 120 divided by square root of t. Question number 21. The functions f and g are such that f of x is equal to 3x minus 1 and g of x is equal to x squared plus 4. Find f inverse of x. So f of x is given as 3, y is equal given as 3x minus 1. We can call f of x as y to make it easier to write. And then now what we want to do, we want to make x the subject. When we make x the subject, we can swap x and y at the end. So to make x the subject, you add 1 to both sides. So y plus 1 is equals to 3x. Inverse of times 3 is divided by 3. So y plus 1 divided by 3 equals to x. And then we swap the x and the y. So the x takes the position of the y takes the position of the x. So you can write it as y equals to x plus 1 divided by 3. And that y is called f inverse of x. So that's your f inverse of x. So to find the inverse, write it as y equals to 3x minus 1. Make x the subject, and then you swap it at the end. And the inverse means a reflection in the line y equals to x. Given that fg of x is equals to 2g f of x, show that 15x squared minus 12x minus 1 equals to 0. This is part B. We need to get fg of x first, and I'll highlight fg of x in yellow. So we need to find fg of x. After that, we need to find GF of X. Let's use a color which is far away from yellow. We need to find GF of X and put them together. So we need to find the one in yellow and the one in blue, and then we will put them together as is given in that equation. So that equation, I will put the equation in red. This is the equation that we want to make them to look like. So let's go. FG of X, whatever GA of X is, G of X is X squared plus 4. We take that and replace the X in F. So the X plus 4, which comes from the G of X, that replaces the X in the F of X. So that would give you 3 bracket X squared plus 4 minus 1. For GF of X, we take F of X, which is 3x minus 1, replace the X in G of X. So 3x minus 1 takes the place of X, and that becomes 3x minus 1 all squared plus 4. We put it in that equation. So FG of X, 3x squared plus 12 minus 1, I've expanded it, FG of X, is equals to GF of X. That's GF of X there. And there's the 2 in front, which is given in that equation. Now, what we need to do is 3x squared, 12 minus 1 is 11, equals to 2 bracket. You expand 3x minus 1 all squared, would give you 9x squared minus 6x plus 1 plus the 4. Now, you remove the bracket. 2 times 9. 2 times 9 is 18. That gives you 18x squared. 2 times 6 is minus 12. And 1 plus 4 is 5. 5 times the 2, it gives you 10. You subtract, you put all of this to the right-hand side. So that means the 3x squared can go to this side, and the 11 can go to that side. So what you have is 18x squared minus 3x squared is 15x squared. And there's minus 12x. And then 10 minus 11, it gives you minus 1. And that's equals to 0. And that is what you are required to show. Question number 22. There are only R red counters and G green counters in the back. A counter is taken at random from the back. The probability that the counter is green is 3/7. That means 3 green counters and 4 red counters. The counter is put back in the back. 2 more red counters and 3 more green counters are put in the back. So 2 more red and 3 more green are put in the back. A counter is taken at random from the back. The probability that the counter is green is 6/13. If it's 6 out of 13 to be green, 13 minus 6 is 7. There will be 7 red. So find the number of red counters and the number of green counters that were in the back originally. So you added 2 more red counters, so 4x plus 2, and added 3 more green counters, 3x plus 3. That's equals to 7 is to the probability that counter is green is 7 is to 6. Because 6/13 is green, probability of green, and 7/13 for red. So the ratio of 4x plus 2 over 3x plus 3 is the same as 7/6. You cross multiply. 6 times 4x plus 2 equals to 7 times bracket 3x plus 3. Remove the bracket. Or expand. 6 times 4x is 24x. 6 times 2 is 12 on the left side. 7 times 3 is 21x. 7 times 3 is 21. Subtract x from 21x from both sides. 24x minus 21x gives you 3x. And then 12, subtract 12 from both sides. 21 minus 12, it gives you 9. So 3x equals to 9. And you can work out x to be green, to be 3. And so if 3x is 9, so that gives you green. 3x is 9. That means there's 9 green. And then 4x is 12, which gives you the 12 red. So there's 9 and 12. 9 for green and 12 for the red.